All right. So last class, you guys learned how to do this, where you guys took your tools that we made and the part you created from the print, and were able to actually simulate in Fusion the toolpaths necessary to actually create your piece. So this would be what you guys would pull out of the machine when you're done. So now what we need to do is give this code that is created from these lines. So these lines are called toolpaths, and we're about to create the code that we will send to the machine so the machine understands where to go. And this is called G code. Okay? And it's every single machine that moves in an XYZ pattern understands G code. Okay, whether it be the CNC mill or the CNC lathe or the CNC router or the 3D printers in the room or the laser, they all operate in G code. Now, the laser obviously doesn't deal with Z values. It only deals in X and Y's. That's left and right movements. The 3D printer has to deal with left, right, and up. Now, everything is always X, which is this way, Y, which is this way, and then Z, which is straight up and down, which is what the tool is doing specifically for drills. Okay, so there's drilling up and down, but every time a tool goes up, it's in the Z direction. Every time a tool goes down, it's also in the Z direction. It's just negative. X and Y is left and right, and Y is forward and backward. Maeve, you're going to knock that chair over. Stop. Yep. All right, so here's what we're going to do. I went ahead, and you're going to have to go through each tool and make sure that each tool in your tool library is calibrated to a specific tool holder. Now, this is done pretty easily. So I just went ahead and did it in order, and I got lost, so I went ahead and popped this down so I can see what tool I'm using. So the second operation, which is my contour, is the same operation as the other contour. So my offset or roughing contour is using that's 3/4. Okay, so I went to my tool library, and I went to my NIMS, I went to my 3/4, double clicked on it. It brought this up. This is where we changed all the geometry of it. But here in the post processor, we have to tell it what tool holder we want to be in. And I chose 2. If I want to be in 8, that's fine. I hit OK, but notice it does not update. Okay, it still says tool 2. So what I need to do is go into this operation and reselect this tool for tool 8, which is here, 3/4, but now instead of 2 it says 8. Hit OK, and now it updates to tool 8. Notice this one is still tool 2, so I'd have to go in and do the same. So go in, reselect, make sure it's tool 8, okay, and that would change that. Now what I really want is I want it to be tool 2, because that's where I have it in my other machine, and I'll show you why that is in a second. So what you guys need to do is take a picture of this. Okay, I'll pause for a second. Pause that when you're ready, and you'll change all of these to match my tool numbers. Okay, I want always the 1/4" drill bit to be tool 7. I always want the .213 tool to be tool 6, all the way up. Okay, so once you guys have that done, let me go back in here and change these back to tool 2. Tool 2 is 3/4. Tool 2.
Jumping jacks.
You are jumping up and jumping jacks. Okay, so this is everything I want. So, just like in the simulation, if I only select one of those, or if I start selecting 2 of them, then I will only have those operations. Notice this will not do the pec drilling or the slot, because I've only selected the first 3. If I select all of them, okay, then it will run all of them. So I can choose what operations I want to do. It's very, very important. If I select the setup, because I could have multiple setups on a part, I could do a top, I could come down here and do another setup, and do a whole operation on the bottom, okay? I don't want to do that, but I'm just saying I could. So you have multiple setups on the same part, okay? So let's say I did this, set this here, and I could do another facing operation just to show you. Let's choose my facing bit. Yeah. 3-inch face mill. Get out of here. Okay. Now you guys can see I'm doing I have the same, but I have a different setup on here. So it's just very important that you guys select the right thing. So once you guys get into multiple things, you'll see this. But I can select both setups, run this, and you'll see they'll actually switch. So I'm doing the bottom, and then I'll do the top. Now, we don't have that capability. There are some machines that can flip your part up, down, and do different things on a rotational axis. Those are called 5-axis machines. We don't have that. We only have a 4-axis machine. So just keep that in mind. But I do not want this, so I'm going to go ahead and delete it because I don't want it. I mean, I could leave it. Whoa. Whew, that was interesting.
Daddy.
Okay, there. Whew, that was scary. Yeah, okay, kiddo. Alright, so here's what we're going to do. I'm going to select everything by selecting the setup. I'm going to hit post process. Now, in here, there are, built into the system, hundreds of post processors. I'm sorry, that's not true. There is 107 post processors built into the system. Okay, our machine at school requires a Haas A-axis post processor. Okay, the CNC router requires this. Where is it? CNC post processor. So it's a different post processor than the Haas. I think it's under generic. Maybe after we upload it, that's weird. CNC router. I think that's the one. So that one would be, if I wanted to send this program to our router in the corner, that yellow stinger, I would have to use this post processor. Okay. If I want to use the Haas machine, I have to use this post processor. It will not work if I chose a different one. Does that make sense? Every machine has its own post processor. If I was running a Funic, okay, CNC, I would have to choose the right Funic post processor, and your machine will come with its own post processor. Like Ivy Tech has 3 different types of machines. There's Haas, there's Funic, and then there's I can't remember the other one off the top of my head. But they all require a different processor because Haas has some codes that don't exist for Funic. There are proprietary codes like cutter compensation, which we won't go into right now. But that is a specifically Haas code. There are other things that have cutter comp, but G91 and G90 are very specific to Haas. I think it's it's G40. Sorry, G40 and G41 are cutter comp and cutter comp off. But that's not important. I have an emulator that I'm going to use called IntelliTech. Okay, this is an emulator I have, and I'm going to call this program 5484 because why not? I'm gonna save it. And that's it. So I'm gonna save it to. I'm just gonna save it to my desktop. Okay. I'll save it to documents because why not? It's an NC. Okay. That's too much stuff in there. Let's just do a desktop. Let's do POE. I'll save it to POE. So I'll save it 5484 POE. Boom. I'm gonna come over to my machine. Okay. I have it all set up. I have my part already cut. So here you can see. This is my part. It's 3.5 by 2.5 by 1.5. Now, I know that's twice as big as it needs to be, but I want to make sure there's some sticking up above the part. So, that's all set. Okay. Boom. Come in here so you guys can see. I'm going to set my corner. So, this is my origin because when we look at this, that's where my origin is. My origin is in the bottom left-hand corner. So, my origin on my machine has to also be the bottom left-hand corner. If I did it over here, the program would run over here in space because it would think this is the bottom left of the part, even though it's not. So it would run the program way over here. Okay, that's not what I want. I want the program to think the part origin is here, just like I set this up. Now I could change this part origin and have it here as long as my X and Y were pointing in the direction of the part. Then it would know that and it would be okay. So wherever you put the origin on Fusion is where you have to put the origin on the machine. So since I chose there, I will choose it. Okay. So I'm going to come down here. I'm going to go File, Open, and this is basically the same thing. There are different. It's a different display. Obviously, it doesn't look like this because it's going to be on an operational display on the Haas. But you're basically just going to go and open it. So I'm going to go to Where did I save it to? Did I save it to desktop? Nope. I think I saved it to... Oh, this is silly. Why did I save it there? Cameras, pictures, no. Did I save it in pictures? Oh, why do I do this to myself? No, P-ring. Alright, so there it is. That's where I saved it. Okay, that's the code. This is the G code. Notice that tool 1 is my face mill. Tool 2, if I was to go down, you would see it as tool 2, which is my offset contour. Okay, that's tool 2. I went ahead and... Okay, here. Okay, I went ahead and updated my tool library to match. Tool 1 is a 3-inch. Or maybe it doesn't go as high as 3-inch. That's interesting. Okay, it doesn't go that high, but you'll see it. So it's stuck at a 2. But this is my face mill. This is my end mill for the contour. This is my end mill for the slot. And notice it's tool 3, and my slot contour right here is 0.25, quarter inch. They all match. Okay, it's very important because if I tell it that my tool here is 0.312, but my tool 4 is a different tool, it will cut with whatever that tool is. That hole is going to either be too big or too small depending on what tool is actually in the holder. If I put a quarter-inch drill bit in that holder and tell it it's a 0.312, it will come out small. Okay, there'll be too much material left on that part. So it's very important. So I'm going to go ahead and run this so you guys can see it. Everything is set up. Okay, you'll be able to see all the G code here. I'm going to take this and I'm going to say run because it's running all of 5484. Run program. It wants me to insert tool 1, so I'm going to hit F5 to do that because that's what this program does. Now I can write the program where it doesn't need my input. So here's the facing operation. Okay. And it's going to go up. It's going to want to switch tools to tool 2. Now in the Haas, we're going to have 10 different tools at our disposal. We have an umbrella, that's what it's called. An umbrella that houses our tools. And we have 10 tools that we can choose from. Okay, now what this is doing is what we told it to do. It's doing this tool path. Okay? Now remember, this tool path is going to... Oh, thanks, sweetheart. Oh, gosh. This tool path we told it to... Here, let me... so you guys can see this working. Okay, I'll leave that there so you guys can see it. So this tool, remember, this first path was the outside, so it's not coming nominal yet, right? This is the roughing pass, and notice that we have 3 passes. So right now we're on our first, okay? I believe it tells you that. Pass 1. Now it's going to go on pass 2. Well, I didn't change, but we should have. So we still have to wait for the second part, which was this one. So right now we have these 2, which are being operated on right now. Now notice I can change the speed here again on this machine because I dialed in my feed rates. Since I told my machine the feed rate had to be 40, that's what it's cutting at, 40 inches every minute. Okay? So for every minute, it's going 40 inches. That's pretty fast. Okay? Yeah. So if I was to watch this whole thing, you'll see it go. So I'll let this go so you guys can see it. Now, this is the IntelliTech machine. At school, we will be using the Haas machine to actually cut this aluminum, which means we'd have to use a different post-processor, which would be... come on. I want all of it. I won't let me show you all of it at the same time. That's silly. Okay. So at school, I would be using this post processor, this Haas A-Axis. And I would do the same thing, name the program, all of that fun stuff. Save it, put it on thumb drive, and send it there. Well, this is the machine. This is the toolpathing. I'm trying to go a little faster. Oh. So far it's taken 3 minutes. It's also on line 7. Now, you guys, for your CNC operation, will actually have to write this program from scratch. And that's what we're going to focus on when you guys get back from spring break. Which, by the way, congratulations on making it to spring break. But once you guys get back from spring break, I will teach you guys how to write this program from scratch. Okay, or I don't know if I'll be able to do the whole thing, because it'll take you a while, especially if you've never done it before. But I'll show you how to break down a print into it's about, I think it's 7 operations when you break it down. And then map it out using Cartesian coordinates, which are X, Y, Z's. And then I'll teach you guys the G codes. G00 is go as fast as you can. Right, so like this machine, right now, the code is G03. G03 is a radial cut, so it's cutting that radius there, right here on the corner. Right now is a G01, which is a linear feed rate, because it's cutting a straight line. So G00 is go as fast as you possibly can. You never use that for cutting. G01 is go with some speed. So I'm going to tell it to go with a feed rate, right? G00, no feed rate, just go as fast as you can. You okay, kiddo?
Yeah, just off. Just off.
You just coughed?
Mm-hmm.
You need some water? Thanks. There's no more water? I think Mom will be able to help. These cookies turned out really good.
I know.
So the guy who made them. So G00 is go as fast as you can. G01 is go at a feed rate I tell you to go at. So I've told it to go at 40. G02 is a radial cut, so it's going to cut a circle. So it'll go in a circle. I'll have to go until a radius, and that's a clockwise circle. A G03 is a counterclockwise circle. And then a G04 is a dwell, and they go on and on and on. There's also machine codes, M codes as they're called. Like M08 is a turn coolant on function. M09 is a turn off coolant function, and they go on from there. M03 is turn spindle on clockwise. And then you'll see, so this N177 is the line number that it's actually executing at. So it says N184. Oh, here we go. Boom. So now we're going to do our little slot. So N's are line numbers. They don't actually affect the code. You just put them in there if you want to keep track of what line. So let's say this slot broke down and didn't work the way I wanted it to. I love you too, kiddo. And then I could see where it broke down. Oh, look, it broke down at N17 or N217. So I'd have to go to N217 and fix it. If I don't have those lines, it would actually be harder to debug my program. Mwah. I love you, kiddo. I love you too, the mama. Yeah. So we'll finish this out. There's not too much time left. And after this, there's just 4 pecking operations, and then we're done. Again, this part is too tall, but the machine doesn't know that because I told it to go at the top of the part. So everything I programmed is from the top down, so it won't go any farther. But I did exaggerate the height of my part just to make sure that it wasn't gonna hit the vise in this this emulator. Yeah. So if you guys have any questions on how to run post-processing, please feel free to hit me up. All you're doing is turning in your post-processor. So this is what I want. This code. I want this code. Okay, so all you're going to do is turn in this program that you've called whatever you want. Okay, I want that program turned in on Canvas. The holes are real easy. Boom. Boom. Now normally the machine would do this automatically. I wouldn't have to sit here and keep changing the tool. Also an M command, so this would be an M06. MO6 is a tool change. So instead of me hitting F5, you would just put in your code MO6, and it would change the code out. And that's it. There's our part. Boom. What do you think? I think it turned out pretty well. Boom. Alright guys. Let me know if you have any questions.